Hey, Game Audio fam. This is, I guess you could say it's sort of a update video to changes that were made in Soundscape for the city sample. So, if you all played the demo that we released last year called the Matrix Awakens, or if you've downloaded and tried out the city sample demo project, then you will have heard this updated version of Soundscape. There's a bunch of stuff that I added that I thought would be sort of fun to go over and kind of explain where it comes from, the philosophy behind it, I guess. So here we can see I have a starter third-person template project with some custom world. I think this is like the world partition map starter, and you'll see these. There's these long drone cicadas in the distance, and then there's nearby, like on the ground, grasshoppers and some nearby cicadas. And so one of the things that I really wanted to add, basically they were an expansion of the spawning behavior features, but there's also a sort of new advanced spawning behavior, which includes what I would sort of call conditional spawning. So one of the features that I wanted to add for the ancient game, but I just never got around to it, was this idea that you would have a async trace that would allow you to move the sound to a surface. And so that's what these grasshoppers and cicadas are doing. Basically, they're spawning in a cloud around me, and then what they're doing is they're firing an async trace down. And then they, if they hit something, in this case the ground, then they spawn, and if they don't hit something, then they don't spawn. So if I go to this rock outcropping, you can see that they're actually spawning on the rocks, which is cool. So some might spawn underneath the rocks because they're trying to spawn in a cloud, a spherical cloud around the listener, which is the camera. And so if I put the camera up above like this, it's more likely to spawn on the rocks themselves. Right. And then of course if they so let's take these. Let's see if I can show you real quick the grasshopper color. Here is an example. So there's a couple of extra things I think that I added. Let me think. I added this. I expanded this clamp height parameter, so now there's a relative and absolute altitude. I think originally it was just relative. And rotation was always there. And then here's the advanced spawning behavior, which is this little drop down. And one is called position by trace, that's what we're talking about here. And so if I bring this to say 500, then the trace, or actually let's do 200. Then the grasshopper trace will only happen 2 meters around the camera. So I think if I go into this spot here. I might have to close them in around the... Yeah, there was one like right on the rocks to the left of me. Let's see. Let's make them go closer. 250 and go 750 as the max out. So now we got a grasshoppers sort of spawning right around the camera, basically. And if I go up over here and hang over this ledge, then they're less likely to spawn. Right? Only right over the... If they spawn right on there. Yeah, exactly. Right. Right on the ledge there. So that's a nice... That's one of the things that I wanted to add for the ancient game, and I didn't get a chance to just because of the time or whatever. And the reason I wanted to add it was... I don't remember if y'all remember, but the ancient game had this sort of bridge that you walk across, and I had these skittering gravel elements, colors, and those... Let me set this back to the original. The original values. Cool. Okay. Anyway, I didn't want those gravel stones to spawn in the air. I didn't like that. So I wish they had stuck to the surface and then. But anyway, so that's one of the conditional spawning things that I made for the city sample. Although that was motivated mostly by the ancient game. The other one that I made for the city sample was motivated by a problem that I had specifically on the city sample. And actually, let me use a different color for that, this B color. And that was I needed to have basically, if y'all weren't aware, aside from the drivable vehicles and the metahuman footsteps, the rest of the ambient environment sound in the sort of city sample or the sandbox city was implemented just by me, all by my lonesome. And one of the problems that we had was that the city was being regenerated every week, maybe even twice a week. And so the geometry was not guaranteed. Like if I placed an ambient sound actor in a location, I couldn't be guaranteed that location would still be whatever it was, like a road or a sidewalk. Like the city was being changed every week because it was being procedurally generated in Houdini. And so as a solution to this, what I worked out with the Houdini team was for them to generate a point cloud just for me. And basically, I created a system that I call the color point system. And basically what it does allows you to only spawn a sound in an area that has a certain density of metadata, matching metadata. And so, as an example, I have this bee sound that I recorded in a sort of wildlife preserve out here in Washington. And I like in this case, I only want the bee to play when I'm near these like flowers. So these flowers over here. We'll say they're flowers. They're not. They're just, I don't know. Let's just pretend they're flowers. Anyway, I only want bees to spawn around those flowers. So basically what I did is I made it a condition that the bees can only spawn in the presence of certain density of flowers and that's this color point system down here. So in this case, it can only spawn in the presence of 2 flowers. And what I mean by that is that at some point, in this case, it was at the beginning of the level, all those flowers were added to what's called a spatial hash map. And a spatial hash is basically like if you took 3D space and you segmented it into a bunch of grid cubes. Kind of like how the ground is like a bunch of squares. So you can imagine the squares as a representation of a location in space. So let's say, let's just take these squares, and I'm just standing in this white square here, or this lighter square, I should say. And this lighter square, anywhere I stand inside this lighter square, I am inside this square. And so the way that a spatial hash, or a hash map, sometimes it's called, the way that it works is it allows you to very quickly calculate whether or not a vector coordinate is inside of a grid. And what's cool is that the grid is just given a sequential number. So it's basically collapsing space. Or let's say in the case of this floor, if we were just looking at this floor, collapsing these 2 dimensions into 1 dimension. And we do that by, say, like giving each grid space, it's just a number. It could be like 1, 2, 3, and then 4, 5, 6, and then 7, 8, 9, and then you have like 9 squares, right? And so it's like a very quick calculation to determine, say, oh, I am now in square 5, or I am now in square 4. So that's basically how spatial hashing works. And you can do this with any dimension of space, which is really cool. So you can do this in a 3-dimensional space, and that's what I do for the color point system, because I want it to be, first of all that data, all that information to be condensed into something that is a small memory footprint. So I want to shrink the memory footprint, right? I want to know generally how many flowers are in a specific area, but I don't want to store every vector for every flower. What I want is I just want to know, hey, in this segment of space, roughly how many flowers are there? In this segment of space, roughly how many flowers are there? And so that's the spatial hash was created at the beginning of the level. On the city sample, if you look at the city sample, I actually create the spatial hash before gameplay, before the level in the editor. And it's stored on a local actor called the World Audio Data actor. I won't go too far into that, but that's basically a system that I created to store that data in a local way, so that as the player moves through space, it dynamically loads that data in and releases it, using the world partition as sort of a streaming manager. In this case, I just took all the vectors in the beginning and I just fed them to Soundscape, and then Soundscape turned them into a spatial hash. And so right now I'm actually trying to spawn bees, like roughly once every half a second I'm trying to spawn a bee. And I'm failing to spawn a bee. And so if I go over to these flowers, you'll start to see, yeah, there's a bee, that I'm starting to spawn bees. And all it means is that I am, these bees are now, and the way that it works is I just run the same calculation for the bee that I ran for each of the vectors. I was like, give the vectors, and then it spits out a grid number. And then I look that grid number up, and I just see how many flowers are in that spot. and that's how the color point system works. And so on the city sample, what I was able to do was do stuff like, big traffic only happens in a certain part of town, like on roads. So if there's a building, you won't hear traffic. You won't hear a horn honking in the side of a building. You'll only hear a horn honking. Well, actually, I also use the color point system in conjunction with the AI to do horn honking and the metahuman shouts. So if you heard metahumans speaking, yelling at each other, or having conversation, that was basically with AI every 5 times a second. I get the closest 150 metahumans and the closest 30 cars, and I determine which ones are standing still, and then the ones that are standing still, I feed that to the color point system, and then there's a possibility that the a horn will honk in that spot near a car where that's standing still, or a metahuman might shout if there's like a metahuman standing on the corner or something like that. So, that's an example of like when you take away the metahumans, or you lower the density of metahumans in that the density or frequency at which people yell also reduces, and it's just sort of naturally reduces because there are no people around. So I also did. So here, I think I also set it up so that I have some crickets that you can hear because of the ferns, and you've got some birds because of the trees. And if I actually go deep enough, then I actually change to like a forest state. So what's cool? So that's one of the nice things about the color point system is I can have these trees registered as vectors, and then I'm basically spawning stuff that'll be around trees, and I can get a sense of that transition before I like completely change state. And this was sort of like a roughly put together map, but yeah, I think you get the idea. So let me just quickly show how the color point system can be set up. Come on, give me this. There we go. So you'll see I'm using gameplay tags, and I'm just saying there has to be at least 2 flowers in a space, and the color point system there's actually 4 color point grids. If you go to the project settings, you'll see that the Soundscape settings have been updated. So we have our default palettes that load here, and then here we have the color point system and how we define the size of the grid spaces. So the LOD1 color point hash is 5 by 5 by 5, and then the LOD2 is 25 meters by 25 meters by 25 meters cubes, and the LOD3 is 100 meters by 100 meters by 100 meters. And so what you get as a consequence is between 0 and 5,000 or 0 and 50 meters, I'm only checking LOD1. And then if a sound tries to spawn outside of 5,000 meters or 5,000 centimeters, or 50 meters, I should say, then it will check LOD2, and the LOD2 is larger. And what you get, this is kind of what's cool about the LOD system, is that if you make it larger as it goes farther out, then you get this situation where you get more, like your grid resolution lowers, and then your color point density goes up. And so you can do big group sounds. And that's how in the city sample, that's how the big city sample city ambiences actually spawn. They actually just spawn where there's like a lot, if there's like medium to distant traffic sounds that just cover, like, they just sound big. Instead of playing them 2D, I actually play them 3D. And I just give them a really long roll off, and I give them a really long omni radius. And you get this sense that there's a directionality that if you go to the edge of the city, you'll actually hear that those sounds are happening. They're only spawning inside the city where there's a lot of city-like color points, and they're not spawning over the water because there's no city color points there. So, and then there's an active color point system, and the active color point system works with a component. So you could give a component to, say, like an enemy that moves around, or an NPC that moves around, and then just tag them with a color point, and then they just update with some periodicity. Like in this case, every second, they'll update the color point, the active the active color point hash. So this is better for like slowly moving stuff. You can increase this, if you want, but this is how you can do group sounds, cluster sounds. You have a bunch of enemies in a space. If I had like a swarm of bees, maybe I would say, like here I have the bee sound will only spawn if there's 2. But I'm sampling 5 meters by 5 meters, right? So if each one of these squares is like 1 meter, then my sample size is like quite large, right? So if I shrink this, where's my project settings? If I go back to Soundscape and then I shrink this, I could do it something like, let's say 150 by 150, and then bring that in to maybe like 2600, and then make it something like 1000. One of the things that I've noticed is that it's better if these grids don't quite line up. It's a little bit more natural that way. Let's do 500. And then 50. So let me drop in. So now my bees, the sample size for my bees is much smaller. So it's less likely to get 2 flowers captured inside that grid space. I forgot the minimum distance. Oh, it's 450. Yeah. So there was a bee. If I'm too close to this big cluster, then we miss this cluster because I have a minimum spawning distance, so I'm not spawning around this cluster if my camera's hanging over it. Nice. Yeah. So that's something, that's another way to, all of it is just tunables. And then the other thing to think about is how large your space is. So, my settings for the city sample were quite large. And the reason partly was because the city sample was so large. and I needed to make sure that my grid space, that I had enough numbers to cover all that space. Let's put it back. I don't remember exactly what it was on. Something like that. So now if I drop in, the bees will be much more prevalent because I'm more likely hitting 2 flowers because my grid size is larger. All right, these flowers are almost half a meter or quarter square meter. So capturing 2 in a meter and a half is a little bit less likely, especially if the camera's hanging over that area, right? So, yeah, and then I could obviously make it so that the bees are only. I could also make it so the bees only have to have 1 flower. In which case I'm even more likely, right? So that's kind of the idea behind the color point system. I hope that was interesting. I think it's a really interesting way to filter out sounds, and it's what I like is it's sensitive to the environment around you, and so to me that's the big part. Like I don't want to have to, like if you're making a procedurally generated environment, you don't want to have to add bee spawners to plants, you know. You just know that bees should spawn near plants. That's all. That's the behavior you're looking for. And so that's the concept behind color points. Anyway, I hope that was interesting for people. Have a good night.